In today's video, here is a nice geometry problem. So we have these are two right triangles inscribed inside of the square with the length number 1. We have these following angles, alpha and beta. We have these following distances, we have x and y, okay? So the question, we are going to express alpha in terms of beta. So we are going to find a nice relationship between alpha and beta, okay? You can express that in any way you want. You can express it in terms of sine or cosine or tangent, whatever it is, okay? The important thing, just find the relationship between alpha and beta, okay? You guys, you can give that a try to this problem, play, get a solution. Go ahead with this video whenever you come back to see us, okay? By the way, don't forget to hit the subscribe button and support the channel, like, comment, subscribe. Now let's jump into the solution. So it's more simple here. Since we have these two right triangles, we are going to apply the Pythagorean theorem on both triangles, okay? So we have this distance em squared. We have em squared, which equals number 1 plus x squared. You will have the same thing for the second triangle, okay? We get mb squared, which equals 1 plus y squared. So the easiest way to make the combination between first and second equation, I'm going to take the difference. This one minus this one. So we get here am squared minus mb squared, which equals this one minus this one. Number 1 it will be cancelled out. I will be left with this product, x minus y factor x plus y, okay? Because we will have a difference of two squares, okay? So the next thing up, I'm going to replace x plus y with number 1, because we have the sum of these distances equals number 1 as the length of the square. So this one will be replaced with number 1. So since we get x plus y equals 1, I'm going to calculate x minus y. X minus y, which equals 2x minus number 1, okay? So taking this value of x minus y and replace it here. So I get the following, I get am squared minus mb squared, which equals 2x minus 1 is multiplied by number 1, okay? Notice here, we are going to find x and em and mb, okay? For em, I'm going to apply cosine here. So we know cosine of alpha, which equals Jason divided by hypotenuse, okay? So I get number 1 over em. I'm going to write em in terms of cosine, em, which equals 1 over cosine alpha. Let's square this one. So we know 1 over cosine square alpha is the same as 1 plus tangent square alpha, okay? We will have the same thing for mb square. So we get here cosine beta, which equals 1 over mb, implies mb square equals 1 over cosine square beta, which equals 1 plus tangent square beta, okay? I'm simply going to take this difference, am square minus mb square. So I get rid of number 1. I will have tangent square alpha minus tangent square beta. So I get here tangent square alpha minus tangent square beta, which equals to x minus number 1. Also x, so we know tangent of alpha equals x, which is opposite, over Jason, which is x, which means x equals tangent of alpha. Alpha, I'm going to replace it here. I get 2 times tangent alpha minus number 1, okay? So what to do, I'm going to move over these two terms to the left and move over back this tangent square beta to the right. So I get tangent square alpha minus 2 times tangent alpha plus number 1, which equals tangent square beta, okay? This one is going to be a perfect square here. So which means I get tangent of alpha minus number 1 quadratic square, which equals tangent square beta, okay? So I'm going to take the square root on both sides. I get tangent beta, which equals tangent of alpha minus number 1 or tangent beta is going to give us 1 minus tangent alpha. If this one is positive, it's going to give us positive 1. Okay, if this one is negative, which means 1 equals tangent alpha minus tangent beta. Okay, so by taking this tangent alpha, by taking this minus tangent alpha to the left, I will have 1 equals tangent alpha plus tangent beta. So we have this difference equals 1, which means this one is bigger than this one. Okay, also since we get tangent alpha minus number 1 is positive, which means tangent alpha is bigger than number 1. Okay, so I get here for this one, tangent alpha, this checklist is superior to number 1. As you know, if tangent alpha equals number 1, which means alpha equals pi over 4, which means this alpha is going to be bigger than pi over 4. Okay, so this one, it will be between pi over 4 and pi over 2. Okay, but for this one, we get the sum of these tangents just equals number 1. Okay, which means alpha is going to be between 0 and pi over 4. Okay, so we get alpha between 0 and pi over 4. We don't have to include pi over 4 here because we already have it here. Okay, so for the symmetry reason, we will have a nice relationship between alpha and beta. When alpha is getting bigger, which means this distance is getting bigger as well. Okay, if alpha is going all the way down to the pi over 2, which means beta is going to be 0. Okay, so we'll have opposite thing here. If we have alpha is getting smaller, which means this distance is getting smaller as well, which means this beta is getting bigger. Okay, so this is the two equations that we have extracted from this figure. So you have ended this video. Thank you for watching. We'll see you next video. Bye.